Hello there. In this video we're going to be looking at transformations. In particular we're going to be looking at enlargements, but enlargements with a difference. Enlargements that actually make the shape smaller. We're going to enlarge shape A by scale factor 1/2 with center of enlargement let's make it the point 2, 1. Now how do you start? Well, you mark on the point 2, 1. That's there. And then there's two ways of doing this. Here's the difficult way. And you'll be asking yourself afterwards, well, why did he bother showing that? You draw construction lines from the center of enlargement as accurately as possible through the key points of the shape. And I've got another line here. Right, then you get your ruler out. Let's find my virtual ruler, which is far harder to use than a real ruler, and you measure the points. Let's just zoom in. Not measure the points, you measure the distance. You don't measure points, do you? There's my little ruler, and I measure the point, the distance from my center of enlargement to the particular point. So in this case I'm going to measure to the top left corner, and it looks like 10.5. So 10.5 centimeters. I then times it by the scale factor, which is 1/2, and that gives me 5.25. I then mark the point that's 5.25 from the center of enlargement. Now it's a bit difficult, so the ruler's getting in the way. So look, I just move that ruler out of the way then. No, I didn't want to do that. Do this. And where was 5.25? It was here. So that's where my first new point's be. So that's going to the top left of my shape. Then measure, what about the top right? So let's put my ruler on the center of enlargement, and it's 12.2 centimeters, I reckon, to here, the top right corner. Then I do 12.2 centimeters times the scale factor, 1/2. So this often comes up in the calculator paper, which gives me 6.1 centimeters. Now let's see if I can mark on 6.1. That's 6.1. Oh, it's there. So that's going to be the top left, top right, my mistake, of my flag. Now I should do that for all the other points, but I'm starting to get a feel here. Hang on, I know the top left and I know the top right of my new shape, so why can't I just draw those in? Well, yeah, I've got the width of the banner part of the flag. Notice that the width is 1 square, whereas on the original it was 2 squares. This should get your mind thinking, well, hang on, everything in the shape is going to be half the normal size, so the width of the banner is going to be 1 square, and so is the height of the banner. So there's the banner drawn. Now, how high is the mast of the flagpole, beg your pardon? It was 4 squares in the original, so it's going to be 2, and there we have it. Now, I was quite accurate there, and by my standards that was a rarity. Is there another way of working out the position of the flags, the key points of the flag? Well, yes, there is. We could use what's called vectors. Let's have a look. Let's look at this top left again. From the center of enlargement it was 2 squares to the right, and 1, 2, 3, 4, 5, 6 squares up. So it was 2 to the right, 6 up. The original was. If I half each of those, I get 1 right and 3 up. So if I went from my center of enlargement and went 1 right and then 1, 2, 3 up, There I get my point, without having to fuss around trying to calculate the distance in centimetres and millimetres. And the other key thing to realise is that, look, if the original flag was 4 squares high, with the banner 2 squares by 2 squares, then if you halve it, it's going to be 2 squares high, with the banner being 1 square across and 1 square high. Okay, now let's just clear all this. Let's look now at negative enlargement. I'm going to enlarge shape A by scale factor -1 with, I hope you kind enough to accept to say me right, I'm going to use COE to stand for centre of enlargement at 3, 2. So first things first, we mark our centre of enlargement, so it's 3 across, and there it is. Now, let's have a look. Let's draw our lines of construction. I'll try and draw these more accurately. Now, in this instance, we have to extend the lines. Not only do they go to the right of the centre of enlargement, they also go to the left. You'll see why in a moment. Now, what do we do? Well, let's have a look. Let's just deal with the bottom of the flagpole. It was 1 square to the right and 1 square up. Now, if I reverse that, because it's minus, the scale factor of enlargement is minus, then that's going to be 1 square to the left and 1 square down. So the bottom of my flag is going to be there. And from that, bearing in mind that I know that the scale factor is -1, so the size isn't going to change, I should be able to draw my flag. There's the bottom of the flag. It's going to be 4 squares high. 1, 2, 3, 4. Let's just get rid of that writing. And everything else, the size of the flag, is not going to change. So a negative enlargement sends it the other side of that centre of enlargement. Had it been a centre of enlargement, had the scale factor been -1/2, then would have had a flag half the size. I'm not entirely sure where it would be. It would be halfway along this length here, like so, but to the left of the centre of enlargement. Well, I hope that was of some use to you. You might be able to get 1 or 2 marks just by using this video. Okay, bearing in mind that, got to be aware, in the higher paper, the scale factors are going to be fractional, or they might well be minus. Okay, thank you for listening.